So let's get started with a very easy question. Which audience do you think the book is for?
Okay, I can start with that one. So, well, this book is in reality for anyone that wants to learn C++. Well, it's some basic knowledge of C++ is needed, but I believe the examples start from the ground and goes up. So you can start with basic knowledge on C++ and get quick knowledge on multi-threading and asynchronous programming and the different tools that exist in the ecosystem to test, debug, logging, etc. Obviously, any developer that has already experience can also get, well, I hope they can get some knowledge, some good knowledge from the book.
I think that's true. So I've seen various standards mentioned in the book, so it's not like one single standard that you use in the book, right?
At the end of the book, for example, for the generator, you need C++23. For coroutines and Cobalt, you need C++20. For the latched barrier semaphore, you need C++20. And the JThread, I think, is also C++20. I think all the rest probably works with C++11, except if some example uses some C++17 feature, search of bindings or some STL specific, but in general, C++11 is okay, except for the most recent features.
Yeah, that's true. And what compiler versions did you use? I saw quite a lot of mentions of GCC 14, but also some other references to Clang and MSVC.
Yes, so, well, when developing the examples on the chapter, we use both GCC 14 and Clang 8, I think it was. So we were using both compilers on Linux. Some examples also were tested on Mac OS. On Windows, I didn't. I don't know if Juan...
Yeah, I did. In Windows, the lock and lock-free code has been tested on the coroutines, except the generator, because back then wasn't released. Now there is generator. Yeah.
Yeah, it's just the newer features. You sometimes have like that some version isn't like available. I think it was Clang, like the parallel algorithms. I don't know if they were like first or last to releases. Anyways, we have an audience question from Sana, and they ask, could you just name some use cases for async programming?
Well, yes. So, for example, let's say that you have a server and you get a request and you want to do something on the background, for example, getting some information from a database or getting some computation. So you can use asynchronous programming for that. So you create a thread, it runs that in the background. When the result is ready, the main thread will be notified and it will get the result from the future or whatever mechanisms you are using. And it's cleaner than using multi-threading that way. Well, the book covers many other examples, as we said, we have seen before, for example, the pipeline, communicating different stages on a pipeline, event-driven programming. So, yeah, I don't know, Juan, maybe you can also...
Also the job systems, there also is a thread pool, and you have a queue, and it starts doing the processing. So, yeah, there's a lot.
Yeah, I can give some examples which I use, like generally anything network related that you kind of, get packets from the network and then you look into them, or like download websites and process that. I have an RSS reader where basically I start kicking off a processing pipeline to download various RSS files from websites, and then that goes into a parser, and then that result goes into the next process. And so often, like, everything you want to be handled by multiple stages or just to be offloaded from the main thread, because the main thread should not be blocking or something like that if you have UI program, for example. So everything that has to use with threads, futures, etc., what we mentioned, is considered asynchronous programming. Now, with such a complex book, I do wonder, and it's kind of fresh, the book, right? So do you know about any errors so far in the book?
Well, the one you highlighted about clicking the links and not going to the page. No, but apart from that, well, it might be some errors, but to be honest, well, no one told us any errata. I don't know if Juan detected some.
No, one day, depending on what happens with the book eventually with time, so one day we will sit down and review it ourselves, technically review it, to see how to improve it, and maybe considering some. By the way, we talk about what is in the book. Some things they make it. For example, the new execution model of C++, that didn't make it because it was very new and really. So for a future edition can be interesting. So that was, but no, I don't know of any errors, but I'm sure there's quite a few.
It might be, to be honest,
very
because, as you know, no software is free from bugs, so even the books should be. But well, if you detect any to the audience, please let us know and we'll fix them for the next edition.
Yeah, and I think it's just writing such a big book, like, also with Patrice, this is similar size and like 400 pages, and yours has also 400 pages. Naturally, something's happening, or some code examples might invoke a UB, which was the...
yes, we have also great reviewers, editors. The book goes through plenty of hands before being published. And many eyes read the content and try to fix the examples, test them, build, compile, etc. So, but well, anything can go under the cracks.
Yeah, I think that's quite normal. But there's a question about Boostio in the audience. So Nikita asks, I heard that Boostio strand does not use logs. Does it use something like a spin log or mechanisms like atomics?
Yes, so the strands on Boostio, what it does is to try to make the different events going in a queue and send them to the IO context. It's a way to serialize the execution instead of having to use logs. Internally, I believe they should use some kind of SPSC queue, as described in the book in other parts. But well, I didn't check the internals to be 100% on that and saying that's the truth. So what we did in the book is to review Boostio and show how to use the library. I didn't check the full internals for it.
True. That's like, you're not the authors of Boostio, so then how does this book help you to write better C++ code?
Do you take that one, Juan?
Well, better C++ is very open, but it can introduce you to things that probably you don't know, and this is always good to have a wider knowledge of what the language offers and the tools you can use in your own applications in your job. So this is probably the main thing, the main way this book can help you write better C++ code. Right? It's not really a book on a style or the type of effective C++ or gotchas or something like that. It's not, but it introduces you to some features that can be very useful. And in general, it's not they are not very often talk about. I think that there's now starts being a little bit of coroutines. Coroutines are starting to be quite a lot in conferences and talks and stuff. But and the memory model, I think that I watched all the talks about the memory model that there you can find. There's not so many. So yeah, this is it. This is interesting, and also it can give you make you interested, and then you can go to the reference or other sources. This is also good.
I can also add that, well, we present different tools, and then obviously when your toolset has many other tools that you didn't know, maybe you can use them more effectively. And also about writing better code, well, there are also chapters about debugging and sanitizing that for sure will detect many common errors and will help on making the code better.
That is, for me, one of the big values of the book, to actually have a chapter on sanitizers and to have the other chapters on the tooling for debugging and et cetera, and testing. I think that's things which we should have more focus on as a community, because tools can spare you so much and save so much time. Threat sanitizers has found so many bugs and things where people thought that their log-free code would be working and worked for years. Maybe in threat sanitizer was just, no, there's an issue. But also it can be quite frustrating with those tools with false positives and more complicated code. And when we're a bit more in the advanced features, you already kind of hinted that, what chapters or ideas didn't make it into the book because just you ran out of space? Or
yeah, so apart from the execution model and executors, I think that probably the atomics chapter is reduced because it's a very complex subject that really require maybe 2 chapters at least. But yes, you have to set a line and a limit in order to be able to finish, right? So for me, it was that, and also the performance. Probably, I'm not sure if maybe leaving it as it is, or because if you go deep, you need to write another book. But the performance probably I would have liked to add a little bit more of and also reducing the introduction. This talking about the inter-process communication stuff. Maybe just write a few lines and that's it. Right? Or what is a process? What is a thread? Well, yes. So this is just something that we could have assumed that the audience knows, but it's interesting to have, right?
Yes, I believe it could be helpful for people that doesn't have the basic knowledge on the hardware, so they focus on software only. So to have that piece, because also is totally related with threads and processes. So that knowledge is needed. Could be reduced, maybe, yes, but who knows? Now it's done, and well, to be honest, we are quite happy with the result.
Yeah, I think that's something you can say. Something that just came to my mind, because asynchrony and parallelism is everywhere today. What about GPUs? Is that something which is like in your field, which you use, or?
Okay, I can start. So, well, when for example, my PhD in 2006 was based on GPU computing using CUDA, but that is not related totally with asynchronous programming on C++. We could use any kind of parallelism, but on the GPU is several cores running a single program and getting a result, instead of different threads doing different work as in CPUs. Nowadays, I don't use too much GPU computing. I would like to, but well, is where I'm working. I don't know, Juan can share his experience.
Okay, so Honestly, GPU programming now is extraordinarily hot and important because artificial intelligence, right? So because of these massive clusters of GPUs, because no matter how much hardware you have, if you can improve the software, you can optimize 5%. So imagine 5% of 10,000 GPUs is quite a lot. It starts to be very important. Also, you have a good argument even for climate, and you use less energy and the same calculations and stuff. GPUs, this has a personal interest. I never worked with this professionally, but yeah, if you can find one and can buy it, because it's almost impossible to, not because they're expensive, but because they're impossible to buy. But if one day this is solved, probably getting one and experimenting. But I think that it's a very important subject these days. And at the same time, the low latency for the communication between processors and different servers is also starting to be important. I remember talking to someone working with distributed systems and so machine learning and stuff. And I asked, well, but if you have a problem, you add more hardware and that's it. He said, no. Optimization is very important, but the problem is that it's very expensive. Optimizing software at that is very expensive. But no, of course it's important. So yeah, but the book, but GPU is about massively parallel software, not so much asynchronous. In fact, you try to avoid that. You try to feed the GPU as much as possible to keep it busy. So yeah, it's a very important subject.
Yeah, but also from my own knowledge and experience, the C++ standard does not yet fully embrace this, especially like if you want to be more specific about GPUs and have certain features. There's things like Sickle, CUDA, etc. out there. But if you like, your book has quite a focus on the C++ standard, and the C++ standard is not yet there. I think earlier I saw a mention right in the audience of the upcoming C++ 26 features, like especially executors. Yeah. Are you familiar with these?
Yeah, so I said, well, SIMD probably is not so much for asynchronous. So, and STD execution, as I said, that didn't make it. So probably STD execution is one of the most important new features. Looks like C++ 26 is going to be another C++ 20, like a very big release. And STD execution, yes, is a very important, but it was too far in the future for this book, so probably that was the reason.
Yeah, I think that you still have a lot of space left to write a second book for and yeah, C++ 26 is nice, but it's also still very far away for implementations and usability. And I know that more than 10 years ago, I talked to Scott Myers, and he was excited about the new standards, but also he told me that a particular thing he didn't like was basically that everyone asked him questions about things where he was like, I need to figure that out, but we don't yet know like what Scott Myers would say to C++ 14 when C++ 14 is released, and basically it's not really available on many compilers. And so I think writing books is always a thing where you can't be too much on the cutting edge. That's, I think, something for conference talks and blogs. And then you might, turn those later into books when things are more. Anyways, thank you for your time. Let me see. To the audience, if you have any more questions, now is the time. Yeah, here's a question from the last time we talked with Petrus Roy. about shared pointer, and shared pointer also is very popular to be used to share things amongst various processes and threads. So I thought I pick your brain on what do you think and how do you use shared pointer?
So I studied shared pointer from the synchronization point of view for the book, not to write about it in the book, but to see how the atomics were, and the memory model of this is very well done. Shared pointer is a very complicated, it's very complex. The implementation has details that is very complex. I think the Microsoft implementation, I'm not sure of this, I'm not 100% sure, because I don't remember the details exactly, but I think it uses a non-standard C++ feature implemented by with the Microsoft compiler for this big, and this is to achieve the make shared in a way. It was something to that, and the keyword was novitable, which is do not create a virtual table for this class, something like that. But I don't remember exactly the details. When after seeing that, I thought, well, okay, this is a very strange world. So shared pointer, yeah, well, I mean, these days they say that you should never use row pointers. I think that you should never use or use this or that. It's always very relative and depends many times on what you're doing. Shared pointers add their own little overhead. The synchronization, yes, well, yeah, because it's atomic. You need to be very careful because they are not fully thread safe. And yes, and remembering years ago, working on a bank, there was a discussion of shared pointers, and someone said that because of the atomic operations, they could be very inefficient. So you could have a lot of inefficiencies if you start copying and passing around shared pointers. So what you should use? Well, if you share the memory, in general, because I focus on performance, really, mostly. In general, you want to share at the minimum possible. If it's possible to avoid sharing in any state, any memory, it's better, right?
Mm-hmm.
So yeah. But it's I remember studying the code, and it has its little lessons. In fact, there's very few blogs or articles going deeply in the implementation, in the real implementation, in the standard library. Also, different standard libraries implementation do it in different ways. And the Microsoft has an advantage, and is that the Visual Studio Debugger is very, very good, and you can it's really very good to study code. But the implementation can be dark sometimes in general. So yeah, I remember not seeing very much shared pointers in the code I work with.
Yes, from my side, I should say that it's best to use these managed memory pointers, so shared pointer, unique pointer, etc., because you avoid many issues with you forget freeing, etc. But it's true that when you want performant code, most of the time I see row pointers and also unique pointers, obviously. No shared pointers. Shared pointers, they try to be avoided because obviously they're increase on performance penalty and maybe you don't need to share ownership. It's best not to share as Juan highlighted before. So that's my point.
Yeah, as my own kind of feeling is that you should be very careful with shared pointer and not overuse it, because you share the context, and that often, like, it's like one of the earliest examples I had was learning about shared pointers was seeing a slide where two instances of shared pointers were like connected through the actual instance. and around that was an out trace, and that formed a heart. And I was like, oh, great, Sean Parent also loves shared pointers. And later in life, I got to understand when I watched this again, because I was at a conference, and you have to, some talks you have to watch again, especially with Sean. And he made the argument that basically you have a shared context, and that shared pointer should be seen as a global variable, which it kind of is. So as you said, like for performant code is anyways not really often the best thing, but then also it can make it difficult. And then there's all the bugs you can have with cycles, but that's a different topic. And I think that brings us to the end. I have one more question from the audience about safety critical requirements. I think this is like, Rust ADA is always a hot topic these days. And I do think the book is already covering this very good with the sanitizers.
Yes, so about that, well, first, yes, and that's why, for example, these unique pointers, shared pointers, they were, well, invented, not to try to avoid the pitfalls on leaving memory allocated, etc. Obviously, there are some inherent problems in C++ that makes some other advancements, like in Rust, being difficult to take. So, to be honest, I don't know where C++ will be in 5 years, for example, or 10 years in terms of safety. It will be at the same level as Rust, for example. But, well, let's see. I don't know, Juan, your opinion?
I think that, okay, so C++ really, so every language has its own philosophy, right? I remember I worked with someone many years ago in Spain who used to say, the important thing is not the syntax, but the thing is the philosophy behind the language. So the language behind C++, there is some basic thing, and it's control. C++ is about control. I want total control of the memory, of the resources, of the threads. I want to access the operating system. So I want total control. So when I want total control, I know that there's going to be risks, right? And this is a trade-off. So that C++ eventually will have some safety, probably yes, but I'm sure that they will also let you not follow them, because in C++, I think that, well, Stuart said, there's only two kinds of programming languages: bad programming languages and the ones nobody uses. So exactly. So it goes and lives by itself and has a life of itself, and nobody ever thought it could be used in these systems or other. So probably tooling is going to be an important part. The memory safety, I'm not sure what they're going to do with that, but there's an argument. If very, very few people really need the total control, then you can go on using C, and then all these languages evolve to a more safe model, and we avoid problems of memory and memory overruns and memory leaks and weird pointers and stuff. But I think that, as Stuart also said, C++ is a difficult language for serious programmers. This curious quote has not been written very much. I think he said that. So what he means is that this is not easy, right? So my friends, this is going to be tough. What I think is sometimes C++ is going to probably unnecessarily hard or unnecessarily obscure, or because if you look at the standard library code, I understand that the library code is complicated and obscure because of the many use cases. Because also some people will tell you, well, your byte is 8 bits, but the standard doesn't say that. or you live in the Intel world, but there's many different flavors of software that C++ can work. Can this safety and stuff? I'm not sure. I don't know. I think that probably maybe for that C++ is not the way to go, and you need to create a new language. The famous language which wants to be born out of C++, that famous language, I'm not sure what it is. So yeah, I don't know. We never know. I think that something that I noticed is that this metaprogramming is starting to fade in a little bit, because 10 years ago, this was like a crazy. Now it's fading a little bit. So complexity just for complexity's sake is not really very, very good. But for me, yes, C++ is about you have total control. So if other languages, no, for me is you don't have so much control, but performance is going to be good, and you can implement the systems are going to be safer. So then probably it's interesting for some applications. Some other languages is, well, I don't give you any control, and performance is not the best, but you're going to be very productive. This is another use case. So you cannot have everything in one language, I think.
Yeah, that's true.
What can be done as well, is to go to the tooling and create tools that only compile the program when it's completely sanitized. Obviously, this is quite an ideal world, but it's like what Rust does, isn't it? If the program compiles, it's safe, but making it to compile is quite difficult. So I think C++ could also go to that side, trying to make the tooling more strict to make avoiding undefined behavior, memory leaks, etc.
I think that one should have in mind, especially when we talk about asynchronous programming, that the new languages necessarily do not protect you against deadlocks and data races. They may help you to have a more secure code, but modern C++ also achieves that mostly. And you have the sanitizers, as you mentioned. So we've crossed the hour a few minutes ago. So I think, thank you for your time. It was a pleasure to have you to see the book. Let me bring up the book one more time. So this is actually a book. Let me scroll. All right. So thank you for your time, Javier and Juan. It was really nice to have you on the show. And
well, yes, thank you very much for your time as well. Thank you for inviting us to share this with the world and having us here. Thank you.
Great. Thank you.
Yeah, you're welcome. Thank you, and thanks to Pact to providing this. And with that, I'm going to take us offline.